Okay.
So,
So yes.
during the elastic zone,
Uh-huh.
is the actual strength of the steel decreased or it remains the same?
This one.
I'm saying, yeah, during
Okay.
the elastic range,
Yes.
does the actual strength of steel remain the same or it degrades?
The actual strength of steel normally is not reached at this stage because, as you can see here, the yield point, this is the yield point. So when the steel is subjected to loads that does not exceed the elastic range, it means that the load which has been applied to steel is lower than the yield strength of that particular steel. Clear?
Yeah, clear.
Okay, thank you. I will explain later in the coming slide the meaning of this yield strength as well the ultimate yield strength of the steel. Okay, we shall see it in the coming slide, right? So let's look on this now. So we have the structural steels. Yes? Any question? Okay. So according to British standard, BS 5950 part 1 of 2000, the one that I gave you through your email, we say that the structural steel is produced in 3 structural grades. It's produced in 3 structural grades. These are called S275, S355, and S460. So this one here, S460, this one is the strongest among the 3. And the lowest grade of steel is S275. Okay? So in this classification, S stands for the word structural, that is S, this is the structural. And the number, which is in this case, for example, is 275. This one indicates the yield strength of that material. So if we say S275, we refer to the structural steel with the maximum yield strength not exceeding 275 Newton per each square millimeter. You get the point? So if we look on S355, this one defines the structural steel with the yield strength not exceeding 355 Newton per square millimeters. The same to S460. Now, according to British standards, we say we'll find steel exists in 3 grades: S275, S355, and S460. Clear? Now, so the steel, which we have defined the grades, this one, we shall find now steel of these grades either being rolled or formed sections, or they can be compound sections. They can be built-up sections, or they can be rolled, cold rolled open sections. Now, let's look on the rolled sections. So the rolled sections, this one, they are manufactured in factory by the process of rolling various steel sheets, which are bigger in size and can be formed in these shapes here, you see? So this one here is the I shape or H section. This one, I think you can see it. This one here is the channel section. This one here is the square hollow section. This one here is an angle section. And the last one here, you can see it is a T section. So all these one, they are formed in factory by rolling the steel, can be the steel bars, very big bars. So you may have a rectangular section of the bar. Then when you roll it in machine, in special molds, then you can get a section like this one, or a channel section like this one, or a square hollow section like this one, as well as an angle or a T section. So this one, they are formed in factory, rolled in factory, and a very, or a certain temperature, right? You take special steel bars, bigger in size, then you put them in the machine or the roller. Then after that, you'll have a shape like this one that have been explained here, which can be the H section, the channel section, square hollow section, angle sections, T sections, among others. So these, they are rolled in machine or in factory. Yes? It's explained here that the rolled and formed section are produced in steel mills from steel blooms. These steel blooms, they are very big steel bars. Okay? So you can get the required shape by passing it in a series of rollers. And by so doing, you'll find that you get this form here. So this one, they are not, they are fabricated in special, by using special rolls or rollers in a factory. So the main sections from the rolled and formed sections will include universal beams. See? Universal beams, these are beams that are I in shape, I-shaped steel. Or we have the universal columns, or we have the joists, or angles, or channels, or T's. So if we consider the universal beams, you can see here, we say this one have very efficient in resisting bending moments. So universal beams, these ones, they are lateral members with high strength in resisting bending. If we consider columns, this is their H section. So for example, if you look on the top section, which has been expressed as H section, this one, the difference between H column and I beams is the length of this part here. This part is called flange. This part is, we call it a flange. And this one here, also flange. And this one here, we call web. So the difference between I-beam And H column or H section is that the length of the flange of the H section is greater than the length of the flange in I beams. That is the difference. Later, we shall see this, but currently understand that the significant difference between a H section and I section is that length of the flange in H section, this one, is bigger as compared to the length of flange in I beams. So this one, they are normally used as columns, while this one, they are used as lateral sections. So you see, that is the universal columns. We say this one, they are produced mainly for the purpose of resisting axial loads. And they have high radius of gyration about the axis to prevent buckling. So I think from mechanics, you remember how did we get the radius of gyration, right? In mechanics. We say that radius of gyration is equal to the square root of second moment of area divided by cross-section area of the section. Do you remember that? Yes?
Yes.
Yeah.
Yes, yes.
Yeah, the radius of gyration. We say it is the square root of the second moment of area, that is I, moment of inertia, divided by cross-section area of that particular section. Its under root is what we get what? Radius of gyration. This means that the higher the second moment of area, the higher the radius of gyration, and vice versa. So yesterday we talked about buckling of the steel elements. Now we say that the universal columns, the H sections, this one, they are very good in resisting axial loads. Why? Because normally they have high radius of gyration. Okay? And the high radius of gyration, we know, is the function of its cross-section area also. So the second moment of area is obtained, it becomes high because as compared to the universal beams, because the size of flange, as I said here, you see here, you see the size of flange will be big as compared to I beams, and hence the second moment of area of that particular section will also be big. And since the second moment of area is bigger, it's obvious that its radius of gyration will also be high. And subject to that, it will be able to resist axial loads while preventing buckling on that particular place. Clear?
Clear.
Okay, thank you. Again, we have the channel. Channel section is like this one. See? This one is the channel section. Simply C-shaped. C-shaped. So this one, they can also be used for beams, for bracing members, even trusses, or in compound members. We shall see later what are the compound members. But the strength of channel sections is not the same as the universal beams or universal columns. So this one can be used to carry light loads or lower loads, or the load with lower magnitudes as compared to the universal columns and universal beams. Okay? Then we have the angle sections. Angle sections are like this one. You see? You see this one? This one here is the angle section. Or simply they called L section because of the shape that they possess. They possess an L shape like this one. So this one can be found in two categories. We may have equal angles or unequal angles. So this one here is called the flange, and this one here is also called a flange. So an equal angle is the one of which both flanges are equal, right? Both flanges are equal in length. Of course, the thickness will be the same, but if the lengths are equal, the length of the legs, if this leg, the length of this leg and this leg, they are equal, then we call equal angle. But if one leg is longer than the other one, then such angle is what we call an equal angle. Right? Are you okay on that one?
Yes, yes, boss.
Yes. Yes. To repeat, I say that an equal angle is a steel angle section of which both legs are equal in length. Okay? Which means that if this leg and this leg are equal, then that angle is called equal angle. But if one of the two legs is longer than the other one, then that angle is called an equal angle. Okay?
Yes.
So this one we say this one they are used for bracing members, for trusses, purlins, and for sheeting rails, as we defined yesterday. For roof or for wall cladding, I think you remember yesterday, we say steel is used to produce or to fabricate the sheeting rails that are used for cladding, for wall cladding. I think you remember. So such type of steel, an angle section can be used. They can also be used for bracing purposes or for making trusses, as well as for making the purlins for roofing works. Then we have the structural tees. Structural tee is this one here. So this one can be formed by cutting a H or I beam, a H section or an I section. See? Tees are used again for truss members, for ties, and light beams. For light beams. I think from reinforced concrete, you remember we had primary beams or the main beams and the secondary beams, right? In reinforced concrete sections. I think you remember it.
Yes.
So the secondary beams, if we don't use reinforced concrete, if we use the steel, then you can use these light beams to form secondary beams. The same way as you use the secondary beams which are made of reinforced concrete. So T-beams or T-sections can also be used to form secondary beams, which carry light weights as compared to the primary or the main beams. Okay? So in short, these are some of the rolled and formed sections. Question to that point? Okay. Then we have circular, square, and rectangular hollow sections. So this one, they are produced from hot rolled coils. Okay, produced from hot rolled coils. So this one, in fact, they are tubes. This one, they are tubes. So the shape of tubes can be circular, can be square, or even can be a rectangular one. This one, they can be used as columns or compression members, but also they can be used as tension members as well. We can find this also in trusses. So the tubes have efficient structural sections as compared to normal compressive members. Why? You know, steel tube sections have equal radius of gyration in all directions if they are square or they are circular. Subject to that, they are very stable as compression members because they have an advantage of having high radius of gyration in all directions. That is one of the advantages of the hollow sections. And that's why you will find that in some construction, you'll find that some people are using just 100 millimeter diameter steel tube as a column in to support reinforced concrete canopies. I think you have seen them in various buildings.
Yes, yes.
Yeah. Why? Because steel tubes have very high radius of gyration in all directions. So they have efficient structural strength compared to other elements. And of course, their costs are cheaper compared to the hot rolled sections. Okay. So the next is about compound sections. Compound sections, this one, they can be formed as by strengthening the rolled sections. You see, I have this one here is the normal I-beam, universal beams. But I can add on top of it a certain plate to increase the strength. So by so doing, what we have is called the compound beam. Or I can double it. So here you have the I-beam, this one, and this one. Then I have added a plate here. So this plate, it will be welded at this point, as well as this point, at the bottom, as well as at top. So by so doing, I'll have a compound section made up of two beams, like this one. Sorry. Or at the mid here, we can see I have joined two channel sections. I have joined two channel sections, this one and this one, by welding them to the plate. So by so doing, I'll form a compound beam. So see, this one we are strengthening by welding on cover plates, or by combining two separate rolled sections. You see, like this one. Or this one, you see, here we have I-beam combined with what? With channel section. We have increased its strength. Okay? Or for this one, we have joined. This one could be an angle section or a C section, L section or C section, but we have joined them by two of them by connecting with the plates. This is the steel plate. Then we have making it a strong member that can resist higher loads than having just a single section. Or we can form the lattice like this one, you see? We have the main members, this one and this one, then we have added another members. So by that process is what we call compounding section, and the resulting section is what we call the compound section. Clear?
Yes.
Yeah, that is the meaning of compound sections. Then we have the built-up sections. So this one, we can see here. You will find that you have a very big load that is required to be resisted by maybe a beam, but you don't have a standard beam that is manufactured in factory, or there is no possibility of using the compound sections. Now, what can we do? What we do now is you find the plates. These are steel plates, you see? You take the steel plates, then you weld it together to form a beam or a column or a box section. You see? So for example, the plate jigger like this one, you see? Remember yesterday we said that the jiggers, they are beam elements, but they have the ability to resist very big loads as compared to normal beams, right? So this one, they are formed by welding various steel plates to form the flange, like this one, and then to form the web. However, you can also use the box-shaped built-up section, like this one. So we have this element, which is welded here and here. Then you have this element that also has been welded here and here. So you form the box jigger. So this one will have high strength to resist loads compared to normal rolled sections. Okay? That is the difference between the built-up sections, the compound sections, and the rolled sections. Okay? Then we have the cold rolled open sections. So these ones are like this one, you see? This one, they are formed or they are processed under cold conditions, not in hot one. And we say this one, they are used to carry light loads. So essentially, you'll find them as purlins or as sheeting rails. And we say we have three common shapes, like the Z, the sigma, or the lift channels, like this one. This is the Z sections. This one is commonly used as purlins, as well as this one and this one. They carry low loads, and their process is not under hot environment. Instead, they are formed under cold environment. Right?
Yes.
Yes. So you see, this is the angle section. I think you can see here very clear. This is called the leg and this leg. You see, leg, leg. So equal leg will result to equal angle section. You see, here we have an equal leg. L1 is not equal to LT. And then we have the bulb angle section. You see, this here, we have something like a bulb. See, that is the channel section. You see, with C-shaped. This is the channel section. You see, here we have the flange, and here also we have the flange, and here we have the web. You see, this is the typical T section. Typical T section. Then you see the I section is this one. You can note the length of the flange here, as well as the length of the web. You see, it is this much. This is the flange, this is the web. These are steel tubes. I think you can see them. See? Yes. So for today, that is the end of the lecture, unless you have any other question, please. Yes, any question?
I have a question.
Yes.
Let's see.
We have just 1 minute. Maybe you can email me your question, then you'll answer it.
Okay, sir.
Yes, yes. You can email me, then I'll answer you. Or I'll respond on your question, right?
Okay, sir.
Okay, so enjoy your day. See you next week on
Same
Tuesday,
to
I
you.
think. Okay? Thank you.
Well,